All right, so for question number 1, part A, we're showing that the cross product of a and b squared equals the magnitude of a squared times the magnitude of b squared minus the dot product of a b squared for any n-dimensional vectors a and b. So another way to write that would be the vector a, cross product with the vector b, dot product with a, cross product with b. So that would equal, because we know that the cross product of a cross b is equal to the magnitude of a times the magnitude of b times sine of theta. So that gives us the magnitude of a squared, magnitude of b squared, sine squared of theta. Well, sine squared of theta, another way to write that, just write that out, is 1 minus cosine squared of theta. So that gives us, when we multiply that over, a squared b squared minus magnitude of a squared, magnitude of b squared times cosine of theta. And so the dot product, another way to write the dot product of a dot b is the magnitude of a times b times cosine. So that gives us a squared, magnitude of a squared, magnitude of b squared, minus the dot product of a and b squared. And that is the answer. For part B, it's a very similar process, similar in regard that we're using those identities of the dot and cross products and their angles to find the answer. So we have a dot b equals magnitude of a, magnitude of b times cosine theta. And we have the cross product of a times cross product. So the cross product of a and b equals the magnitude of a, magnitude of b sine theta. So we put the cross product over the dot product and the magnitudes cancel. So that's the magnitude of the cross product, which is hence why it's in the that because we're dealing with scalars. So those cancel out, those two magnitudes, and we're left with sine theta over cosine theta, which is tangent of theta. So since we have the cross product and we have the dot product, we just need to find the magnitude of the cross product, divide that by the by the dot product, and take the inverse tangent of that, and you would get the answer. So tangent of theta equals the square root of 1 plus 2 squared, which is 4, plus 2 squared, which is 4, over the square root of 3. So that's 4 plus 4 is 8, plus 1 is 9. The square root of 9 is 3, so that's 3 over the square root of 3. So theta equals the inverse tangent of 3 over the square root of 3, which equals, wait a second, calculator. I do not know that off the top of my head. Inverse tangent of 3 divided by the square root of 3, and that is 60 degrees. And that's the answer to part B. And that is question A. Oop.